Hello everyone, today we're going to get started on our page 11 notes, section 9.1. We're learning about circles on a coordinate plane. So we're going to skip past that bell work, that's for us to work on in class. But you can see right here, it says, in the circle below, draw a right triangle using the origin and the point drawn on the circle. So you can see there is a little point right here, and we're going to use that to draw a right triangle. So like I said, we're going to use the origin, so we're going to connect it back to the center of the graph, the origin of the graph. And we're also going to draw a line straight down that connects us to the x-axis. And then we can connect those 2 points together here. And now you can see this little right triangle that we're focused on. Specifically what we're going to do, we're going to label this triangle. So what we're going to do is we're going to label it so the legs represent our A and our B, and the hypotenuse, sorry for that sound, it's my printer, my hypotenuse as C, just like we kind of did before. It's kind of a weird looking C, hold on. C, okay? So set up the equation using the three sides with the Pythagorean theorem. So we've got A, B for my two legs, C for my hypotenuse, just like we did before. And what we know is this is going to represent our Pythagorean theorem, A squared plus B squared equals C squared, right? Now, what we also kind of recognize here is that this piece right here also represents the radius of our circle. So what we know is we could replace our C with R because it represents the radius of the circle. Likewise, what we can do is we can think about our distance formula. So for example, the length of A, since we have this 0, 0 going over here, what's going to end up happening at A is if we take our x coordinate and subtract 0 from it, and take our y coordinate and subtract 0 from it to figure out how far y is from our x, or from our origin, we'd end up with this formula here. So in other words, we also kind of see the circle of a formula, x squared plus y squared equals r squared, is the exact same thing as the Pythagorean theorem. That being said, it doesn't always start at the origin. Sometimes we move it from the origin and things get a little bit different. So a couple things might change, and here's how we represent that. X minus h squared plus y minus k squared equals r squared. So those two changes right there, that h and that k, that represents your movement. Are we moving the circle to the left or the right? And then are we moving it up and down, where h represents that left-right movement, and then k represents that up-down movement. So k is our up and down, h is our left and right. Now notice there is a minus sign in front of it. See how there's a minus sign here and a minus sign here? That means we're thinking about the opposite. So a negative is actually going to move to the right, or a negative here is actually going to move up. And when it's positive, this is going to move to the left and this is going to move down. So we got to remember that it is backwards because of that negative. So taking a look at this first example, we can see it very clearly when we actually go in and do this problem. This first one here says identify the center and the radius. So the first thing I'm looking at is h and k. Those two numbers are super important to us, h and k. Again, that represents the center, but it's going to be backwards from what you'd expect. So since you see positive 1, positive 9, the center is actually at negative 1, negative 9, the exact opposite of what it says. And then this piece right here always represents our radius, but it doesn't represent the radius itself, it represents r squared. So we know that if r squared equals 100, to solve that, we'd have to square root both sides. And when I do that, I get r equals 10, so my radius is 10. So that's how we're going to find those pieces. Let's do one more together before you try that next one on your own. So again, in this one, highlighting the important center pieces here and here. We're going to write that as our center, but again, we're changing our sign. So since the x has a plus 8, it's going to become negative 8. And since the y has a negative 14, we're going to make it positive 14. And again, we know that this part represents our radius squared. So I'm going to set r squared equal to 18, meaning I'm going to square root both sides, and I get r equals the square root of 18. Now 18 can definitely break down. I can make a little factors table out of 18. So starting with 2, can I divide 18 by 2? Yes, we get 9. Can I divide 9 by 2? No. Go to the next prime number. Can I divide 9 by 3? Yes, and we are left with 3. Can I divide 3 by 3? Yes, and I'm left with 1, so I'm done. So I know this would factor into 2, 3, and 3, which means this pair of 3's can come out, and under the square root is a 2 left over. So 3 square roots of 2 would be our radius. All right, so go ahead and try that last one over here, and you should be all set on that. All right, so objective 2 says identify the center of the radius given the graph. So this time they're graphing it for us and asking us to figure out what's going on. So in this first one, we could see that we're moving to the left and then up, right? Left and then up. So left 2, so my center is at -2, and then up 1. So my center is at -2, +1. And then it said, what is the radius? So we're going to count the center to the outside of the circle. So 1, 2, 3, 4, 5. It was 5 units over, so my radius represents 5. Very easy for those. You should be just fine working on those. Let's do that last one together, one more together, and then we'll leave the last one for you. So my center here, I'm moving to the right 4, and then up 3. So I know my center is at 4, 3. And again, for the radius, we're just going to count from the center to any side of the circle. I can go up, I can go down, I can go left, right. Last time I went right. Let me just go up this time to show you that it works the same way. 1, 2, 3. You choose what makes the most sense to you. They're all correct. You can go left, right, up, or down. All right, here it says, using the center and the radius from above, let's write the standard equation of a circle. So we're going to take this that they gave us and turn it into that equation of a circle. Being mindful that we wrote that up top. The equation of a circle is x minus h squared plus y minus k squared equals r squared. So all we're doing is plugging in our pieces here. So this first part, x minus h. Remember, the h represents that x value right here. That represents our h. So it's going to be x minus -2 squared plus y, and then k represents the y value from our center. So it's going to be y minus 1 squared. And then r is this 5 that we got from right here. So 5 squared. And then let's just simplify what we can. For example, here, this x minus -2, we know that double negative there is going to become positive. So x plus 2 squared. Y minus 1 is as simplified as it goes. And then 5 squared is 25, 5 times 5. So really, you could see from the beginning, since this was -2, you're just instantly going to put a positive 2 there. Since this is +1, you're instantly going to put a -1 there, and then just square this number. You're welcome to work it out and do it like I did in all the steps, or you can just quickly jump to your answer, whatever makes more sense to you. All right, let's try B. So in this case, my center was 4, 3. So I know that when I do this, x minus 4 squared plus y minus 3 squared equals, the nice thing is that's already simplified, right? We've already got this all set. +4 became a -4. +3 became a -3. You don't got to do anything extra there. But I do know that this part equals r squared, so r squared would equal 3 squared, which equals 9, so I'm going to put a 9 on that equation. All right, on this second page here, objective 4 says, describe the dilation and the translation used to map these circles onto one another. So we're going to do this one together, and then you're going to try it. So what we're trying to do is we're trying to prove that these two circles are similar to each other, meaning I'm taking A and I'm moving it over here to A prime and then showing that they are the same circle using a scale factor dilation rule. So we're going to start by dilating the circle to make it the same size as the circle. You can see that this circle is getting bigger, right? It started off as this little one and it became this big one. So we need to figure out what change is happening. So the first thing we need to do is figure out how big the radius is. So I'm going to count right here. 1, 2, 3. So it had a radius of 3. Now it has a radius of 1, 2, 3, 4, 5, 6. So it got bigger. If you don't know exactly what to do, sometimes you get weird numbers. These numbers are kind of nice. But remember the formula to figure out scale factor. K is equal to new divided by old. So if I take the new scale factor, which is the prime, it's 6. My old scale factor is 3. Getting ahead of myself. 6 divided by 3 is 2. So the scale factor is 2. So the first step is I need to dilate the little circle to make it as big as this one. So what we're going to do is we're going to multiply everything by 2. So the formula right here in this first spot is 2x, 2y. That's how we represent our dilation. Multiply the x and the y by 2. Now we need to do a translation to move it onto this one. So we are moving this to the right and then down, and we want the centers to line up. So specifically, we're counting just the centers. Let's do that in blue. So I need to get it lined up with the center so it looks like it's moving. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's moving 9 units to the right and then we're going down 1, 2, 3, 4, 5, 6, 7 units down. So 9 to the right and 7 down, meaning 9 to the right is going to represent our, let me switch back to the purple, plus 9, and going 7 down is a negative 7 on the y, and that would be our rules to translate and dilate the circles so they're the same. All right, I'm going to leave an example for you to try. Let us know if you have any questions, and then there's some nice EOC practice down